So, YouTube recommended me The Fastest Sorting Algorithm by Polylog. It was an insightful video, but it really got me thinking about a few famous adages. It's about the journey, not the destination. Ralph Waldo Emerson. Patience is a virtue. Geoffrey Chaucer. Slow and steady wins the race. Aesop, as portrayed in 1971 by beloved comedian Bill Cosby. I'm gonna like and subscribe. You. Unlike efficient O of n log n, where O of n sorting algorithms, naive sorts tend to run in an atrocious O of n squared, a great place to start. An especially doo-doo O of n squared algorithm is bubble sort, repeatedly swapping pairs of non-sorted consecutive elements until an array is sorted. That's way too fast. Frankly, it's hard to unintentionally do worse than bubble sort, so our first intentionally slow sorting algorithm is slow sort, living up to its name. Its procedure is as follows. 1. Recursively sort the first half and second half of the array. 2. Find the maximum of the array using information from 1, then place it at the very end. 3. Sort the entire list again, barring the identified maximum. It diligently follows the mantra of multiply and surrender, and its time complexity is, this. That's way too fast. So, we'll turn to the famed bogosort, a portmanteau of bogus and sort. A basic implementation examines each of n factorial permutations of an array, then, in O of n, verifies whether the permutation is sorted. But come on, n times n factorial is ridiculously efficient. A better implementation would, instead of iterating through each permutation sequentially, randomly generate a permutation each time. So, if you're lucky enough, it will always run in O of 1, or if you're unlucky enough, it never finishes. A similarly fast algorithm is bogosort, which randomly swaps pairs of elements in an array until the array is sorted and runs in factorial time as well. And that's way too fast. Fast sorting algorithms like bogosort or bogosort take about an hour for the n equals 15 case. For the n equals 9 case, bogosort's runtime is, on average, longer than the known age of the universe. Ordinary bogosort identifies candidate solutions in O of n factorial and verifies if one is valid in O of n. We need to innovate on that second part. Here's how bogosort checks if a candidate solution is sorted. 1. Make a copy of the array and recursively sort its first n-1 elements. 2. Check if its nth element is greater than the highest element of those n-1 elements. If so, the array is sorted. Otherwise, randomize the copy's order and start over. 3. See if the copy is in the same order now as the original array. Its time complexity is about n factorial to the power of n. That's way too fast. To get slower, we'll need worst sort, but first, we'll need bad sort. So it's bad sort. Bad sort is defined with a parameter L, an array of elements, and K, its recursion depth. Its base case K equals 0 is a rudimentary O of n squared bubble sort. Now, for K greater than 0, we create a new array P, an array of every possible permutation of L. So we'll deal with arrays of arrays rather than just arrays of basic elements. Then, after sorting P, choose its first element, i.e. bad sort Lk equals bad sort Pk-1. How do we choose K? That's where worst sort comes in. Define worst sort as a function f parameter such that worst sort Lf equals bad sort Lf of n, where n denotes the length of L. Notice that we could choose literally any function for f. A good choice is the Ackermann's function, which grows very rapidly. A42 equals 2 to the power of 65536 minus 3. So something like A4n would be inconceivably large for n greater than 1. Thus, by carefully choosing our function f, worst sort ensures that we attain unlimited inefficiency, whilst maintaining a finite runtime. That's way too fast. Miracle sort has a straightforward implementation. 1. Have faith. However, this isn't the slowest sorting algorithm. Obviously, cosmic rays can flip bits into memory, inadvertently sorting our array faster than we'd like. This really upsets me. Nobody online seemed to know about a slower method, and I was about to scrap this video until I devised something brilliant. The real slowest sorting algorithm. Keep this under wraps. Here's OK Clinty sort. 1. Enumerate every prime number until you touch grass. 2. Waste GPU compute on mining Bitcoin until you find a significant other. 3. Identify digits of pi until your mother stops texting me. 4. Run bogosort.